So this session today is going to cover specifically, as I mentioned, construction noise. Really, we're going to look at, do we need to measure it, or why do we bother measuring construction noise? That's one of the questions we ask ourselves. And assuming that we do, and in a lot of cases we obviously do, then where should those particular boundary noise measurements take place? We'll have a look at that. We'll also have a look at the data that should be captured when we are doing this sort of measurements. What sort of noise parameters are important? What other information is important to go along with that? And then how do we actually do it? What are the sorts of types of equipment? What are the options for actually measuring boundary noise? And of course, assuming you're going to use some sort of equipment, we're not just going to walk around using our ears. What do we specifically have to look for in a noise measurement system? So that's what we're going to cover today. So noise, as you're well aware, I'm sure, is a major source of pollution, environmental pollution, alongside all of the other typical things that come from a construction site, like dust and things like this. It has a major impact on its local environment if it's not managed correctly. And the World Health Organization basically, have said that noise is the second biggest cause of environmental health problems globally. So it is a big issue. And we're measuring noise in all its guises, whether it's occupational, environmental, or whatever else, because it has an impact on people's health. So it is important to limit the exposure to noise in many different ways in all our walks of life, because we know, and there's lots of studies and there's more information coming on all the time about this. It can cause hypertension, high blood pressure. It can cause sleep disturbance. It can really affect people's stress levels, and it also leads to poor mental health outcomes. And I think sort of recently, I think particularly with occupational noise, there's even a potential link to Alzheimer's. So the jury's out on that, but there are a lot of studies ongoing and a lot of studies that have come in recent years that actually show that exposure to noise levels, and they don't need to be particularly high, they just need to be annoying, can impact people's health in a number of different ways. Now, construction noise monitoring, as you're probably aware, is very heavily regulated. There's sort of two sort of statutory things: the Environmental Protection Act from 1990 and the Control of Pollution, of the Pollution Act 1974. And these basically lead to, they set out the statutory position on noise from these sort of activities. And primarily what construction companies and builders, etc., have found that they have to either, or potentially have to put forward some sort of a noise management plan for their particular activity. And of course, construction work can be sort of fairly short in nature, a few months. It could go on for a year, it could go on for much, much longer. And some of the larger projects around the country at the moment, with HS2 and things like that, it's a sequential program of works. So it's moving forward consistently. So we'll talk a little bit about sections 60 and 61. And one of the important things to note is that it's a local authority's responsibility to manage construction noise. And the two elements there, the section 60 and 61, that section 60, under the Control of Pollution Act 1974, is basically a statutory notice that the local authority will put on a site, which basically says, thou shalt do this. And what most developers do is they do the sensible thing, and they put forward, as I've mentioned, a noise management plan, which will state what they're going to do, how they're going to manage the noise, how they're going to make sure that they keep within reasonable limits for the local environment that they're in. And they will apply for a section 61, which is a binding agreement which says this is the way we're going to run our site. Now, what will happen is that normally everybody's agreed and it's all set up. But of course, there are cases where things go wrong and you're going to get complaints. And you could find that a Section 61, which is what you've agreed to, because that's what you know you can deliver, turns into a Section 60, which is something which is applied, which is enforced upon that site or set of sites. And that really means that you've lost control. And having control over the way you build and manage your works is very, very important. So a lot of sites will go for the Section 61 first. Saying that, there are a lot of construction works right across the country that don't need to go that far. And it's because it's local authority controlled, you'll find quite a bit of variation around the country from different councils. What I'm told is that London is specifically hot, London councils, some more than others, on the way they sort of indicate that you should be running things, the levels that you should keep within, the type of machinery you should use and all that sort of thing. So it is quite mandated. Other councils, aren't quite as strict. Behind all this is the other thing I wanted to mention was sort of British Standard 5228, which is the code of practice for noise and vibration control for construction and open sites. And this is a very, very useful document, which I've seen a lot of you have seen. And even if it's something, some of you I know from a different country, you could always look at that and have a look at that. It's a very, very useful document. There are two parts to it. The first part one is noise and part two is vibration. And it's basically there for the protection of the people and the local environment from noise and vibration. So people living and working in that vicinity. And it does a number of things, and it's obviously quite a large document, but basically it enables you to predict, using the tools within there, the type of noise levels that you're likely to make, depending on the sort of equipment you're using. It also allows you to not only predict, but allows you to understand what you need to measure for, and it also gives you lots of advice and things you can do to mitigate that noise as well. So, but there's an awful lot in it. So the idea today is not to go through that standard, but just to mention that it's there and it's all part of this. So just to sort of summarize that, so the noise measurement side of it, it tends to be council driven. If you've got any site, why would you spend money on measuring noise unless it was absolutely vital, unless you're going to be a good neighbour. So many councils have their own construction code. They have a lot of useful information and documentation that you can look at. And the type of things they will enforce are the specific hours of working. So, only working Saturday mornings, not working on Sundays and bank holidays, limiting the time that you're working during the working week, typically from 8 till 6, that sort of timing. They will prescribe whether regular monitoring is required and what that monitoring entails. It may, as I mentioned earlier, recommend different methods of construction or different types of equipment that you should use, but so it varies depending on the local authority area you're in. And it may, as I say, prescribe the levels that you're supposed to both measure and monitor yourself against. So a couple of typical ones there for on-site and off-site trigger levels. So they may even decide you need to measure off-site as well as on-site. 70 decibels LEQ, average noise level, every 5 minutes on-site, or slightly higher as a 1 hour average off-site. I'm not saying that's the case everywhere. It certainly isn't. It's just some typical levels that I've seen from various councils. So we're looking at making noise on the construction site. You can't build things, demolish things, that sort of thing without making any noise. We're going to be using lots of heavy machinery and different tools. The noise is going to be coming from not only what we're doing on site, but the traffic that's associated with it, the transportation of materials, the movement of things around site, any servicing works, that sort of thing. There may be traffic congestion and things, particularly in built-up areas, which are as a consequence of this. And of course, workers themselves, you know, raised voices, mobile phone calls, radios, that sort of thing. So there's a whole sort of variety of different reasons why a construction site obviously makes noise. So looking at it from a good practice sort of side of things, obviously today I'm focusing more on environmental noise because this is a boundary noise monitoring webinar, but obviously excess noise in any capacity is a problem not only to local residents and people working around that site, but obviously workers within the sites themselves. So the Control of Noise at Work Regulations 2005 obviously applies to construction workers themselves. Interestingly, noise causes more off-site complaints for a construction project than anything else, more than dust, more than the traffic, more than unsightly scaffolding, etc., etc. It's noise that causes the most complaints. And because of that, if these complaints happen to be upheld, and most people would complain either directly to the site, but more commonly directly to the local environmental health team at the local council, this can lead to ultimately some injunctions on the business. It can limit the operations of the site, either just the methods of work, the operational times, these sort of things. It can have a major impact on the schedule of a construction project. And as I said right at the beginning, it could switch from, if it's serious enough, from an agreed Section 61, where everybody's happy with what that particular site is doing, to a statutory notice Section 60, which may, again, severely limit what's happening on the site. And what's important with all of these construction works is liaison with the local community is vitally important. Letting people know, knowing what's happening, how long you're going to be there, what are the likely impacts in that local environment on those people, and keeping that community liaison going, irrespective of any particular issues, will always help to minimise the complaints and the impact on the local community. So we've looked at why we're actually having to do this. Sometimes we're forced to do it, sometimes we want to be as a good neighbour, but actually, what we're also looking at is in construction work is if we've got these agreed limits on the boundary as to the amount of noise that's exiting the site, we need to make sure that not only do we measure it to see if we are breaking those agreed limits, but also we want to keep within those limits. So there are lots of on-site mitigation measures that people can use, different methods of working, fabricating as much as possible off-site, keeping noisy plants away from any sort of public areas, limiting the really noisy activities. So sometimes you've got pile driving and things like that. You might want to sort of do that in only sort of limited times during the day and let people know that you're doing it. Not just do it randomly at any point in time. That sort of helps the local community out. Scheduling delivery times, so it's not impacting on the local traffic, etc. And looking at the different routes again for construction vehicles in and out. So different things that can be done. Obviously, BS 5228 is a great document for looking at things to do with noise from equipment, barriers, acoustic barriers, boxing things in, placement, all of this sort of thing. And of course, every site is different. So every site will have its own unique challenges. So it needs to be looked at very carefully. And the key to, of course, keeping to those agreements is really sort of measurement. And it's measuring the noise levels that are exiting the site. And once you've got a handle on that, then you can do a number of useful things with that information. So finally, on the sort of the noise side of this, we've just got some typical levels. As you know, it depends how far you're standing away from these things as to where you measure it. But you know, I've done some measurements on sort of breakers and things like this. You know, they're pretty loud. You know, that this noise is coming from absolutely everywhere. You know, even something, you know, like air conditioning units on cabins. There's a whole range of different noises. But the noise levels are likely, the annoying ones, to be approaching 100 plus decibels at the source, and that is likely to work its way out of the site and start to annoy people if we're not careful. So I'm going to throw a bit of the sort of the background on this and why we're actually measuring. We're going to talk now specifically about sort of boundary noise measurement itself. So, you know, why boundary noise measurement? So really, in a sense, we're not really interested in how loud the loudest piece of construction equipment is. You know, that digger's really loud, you know, okay, fine. But where are the nearest receptors to that noise? So if we were on a construction site in the middle of nowhere and the nearest house was 3 miles away, we wouldn't be as bothered as if we were in the centre of London, near some housing, and we're demolishing an old school and building a new one, shall we say. So we've got lots of housing all around us. What we're interested in is not how loud it is inside the site as such. What we're interested in, what is escaping, what is exiting the site and actually affecting your neighbours from the construction site. And we're measuring that, therefore we're doing that because we're putting the monitors on the boundary, we're measuring the impact as closely as we can on the local community. There will be occasions where some sites will be asked to measure at receptors. That has happened before. But generally speaking, if we're just looking at boundary noise measurement, we're looking at putting measurement points or having measurement points on the boundary, and it's generally in line or at the closest point on the boundary to those nearest what we call receptors, sort of the housing, etc. Could be businesses that's affected by the noise. So yeah, we could put one on a corner of a site, but there's no housing nearby. That's not really going to help us. It's what's escaping our site. We've got and there are various ways of doing this. So we could have basically spot measurements, timed recording. So that's a perfectly legitimate way of doing it. You take measurements with a handheld device on a regular basis in defined locations. And of course, the agreement that you have with the local council could obviously help you in defining where those locations are, of course. The other option is continuous recording, and we'll take a look at the pros and cons of both of those. And as I said before, this may be something that you've already put in your Section 61 agreement, because you're saying, right, this is the way we're going to run the site, and these are the noise levels that we're going to keep within. And this is where we're going to measure it, and this is how we're going to measure it, and all that information would be in that document, so everybody can see what you're actually trying to achieve. Okay. So we'll have a look now at the different sorts of measurement equipment that there is for this boundary noise measurement. We're going to look at what's available, what should be captured in terms of noise data, and then what are the options with the data once we've got it. That's the next section. So I've taken this from the Acoustics and Noise Consultants Construction Noise Guide in March 2021, which actually specifies the standards, and that's taken from BS 5228, which I think was last updated in 2014. So it sort of specifies the instrumentation, i.e. the measurement equipment that you're going to use, and it's basically saying, in their case, in their eyes, it should be type 1. With that is with that specific standard, but in any case, at least type 2. So there's a little bit, before we start, a little bit of, if you look at the documentation, there's a little bit of sort of doubt. Should it be class 2? Should it be class 1? If you look at the guidance from the ANC in their documentation, they basically will say, they would ideally like type 1. but you sort of could get away with type 2, but you might want a type 1 meter somewhere in that environment. And the way I look at it specifically is I say, well, you know, if you're trying to prove to someone that you didn't breach, or these were the levels that you kept within, etc., you're going to have, even though that we know that type 1 and type 2 meters for certain types of sound are going to give you a pretty close reading. You don't want anybody to sort of come at you and say, well, you didn't use the right equipment, it wasn't the right class or type of instrument, and really you know, how can we trust the measurements that you've taken? So my recommendation would be to type 1, or as it's said more usually these days, class 1. And the interesting thing about that statement when you look at it is that that's an old standard. So it means that you can use older sound level meters and older measurement systems. You don't actually, because that particular standard has been superseded by the IEC 61672 sound level or sound monitoring standard. So that is basically saying it's not sort of, you can use sort of older equipment to do the monitoring, as long as, of course, it's accurate and it's been calibrated, etc. And the other thing it's got in there, that last point, is verification of conformity. So we're looking at periodic testing. And so you want to be using equipment that is guaranteed to meet the standards, and also, you know, it's actually calibrated, which I will come on to shortly. A little bit more detail then. What can I use? Obviously, as you know from Cirrus, I've put a couple of sort of Cirrus different pictures of different Cirrus meters up there, so you can have a look. So the first one, and lots of other sound level meters, etc., available, is a handheld sound level meter. So you can use a handheld sound level meter. You can take readings at these measurement points on the boundary on a regular basis, and that's what we call attended monitoring. One of the advantages of attended monitoring is you're there with your ears listening to the sound at the same time you're taking that measurement. So if you get a high reading, you can instantly sort of look around and say, well, that's you know, that's that breaker over there that's causing that, or it's pile driving or something like that. So you've got that instant link between the level that you're measuring and obviously the what's going on the site. The disadvantage with that is you're not going to pay somebody to stand there and do that all the time. So you might do that maybe once an hour, go around all the points once an hour. You've still got the expense of employing somebody to do that, and you're missing all of that noise in between. So handhelds can be used in certain situations, but obviously there is an advantage because you're actually there and you're listening to it. But the disadvantage is, as I say, you're missing out on what's happening at other times, because construction noise is variable, and if you're not there constantly, you will miss certain things. And that's where the second sort of option comes in, sort of fixed or semi-fixed noise systems. There's an example there, put on a lamppost of a noise monitor, which is in a specific position. So these are placed at the boundary in the positions that you've identified. They will measure 24/7, and that's the beauty of it. So yes, it's measuring during the night when you're not working, but it's just measuring levels constantly. So you're not missing anything during the day, you're not missing anything on weekends, etc., etc. The data typically of these types of systems is always available as well, but it is unattended. So there might be some extra information that you'd want to get, because it's fine saying, well, they were really high yesterday, but how, you know, what was actually causing that? You will have logs, construction logs, so you'll know what was actually done on the site, but it's just understanding what was causing that. And I'll come on to how that can be. There's some things that you can actually measure which may help you with that. So those are the two main types of systems, so the handheld and fixed. I say semi-fixed because obviously construction sites develop, and what might be, where the noise might be coming out of one boundary is really bad at the moment. In 2 or 3 months' time, because of where the construction works has gone, the noisiest areas might be somewhere else. So you may need to move your monitors at some point in the future. So whatever you put in, just make sure it's accessible and it can be easily moved if required. So what are we measuring? Those of you who've got obviously experience with sound level meters and such, we're measuring two typical parameters. Yeah, in general, we measure the LAEQ, the A-weighted continuous equivalent sound pressure level, or in inverted commas, average noise level over a specific period of time. So we're not interested in what's happening second by second, we're interested in an average over a period of time. And your noise management plan, or what's in your section 61, will specify the sort of data that needs to be logged. Now with modern systems, yes, you can specify for the actual noise monitoring system to instantly give you sort of a 1 hour or a daily or even a 5-minute average result. But obviously you can post-process that if you need it over different time periods. So there's ways of getting at that data. But we're looking at average noise levels. The other thing we're looking at, and it's not as common, but it is there in some councils insist on this, is the LAF max. So it's the air-weighted fast time constant maximum noise level during a period of time. So, you'd want to know what that level, what was the maximum level every 5 minutes, or what was the maximum level every hour. So the average is telling you something, but the maximum level will tell you something as well. That maximum might be fairly instantaneous. And some people don't like that so much because it's obviously can be affected by noise coming from outside the boundary fence. A siren going past, somebody shouting near it, that sort of thing. So you've got to take that with a little bit of a pinch of salt. But those are the two typical noise measurement parameters that construction site monitoring uses. There are others, of course. With sound, you've got sort of frequency information, octave bands, third octave bands, statistical levels, and a whole bunch of other stuff. But those are the two typical ones that most sites work off. The other two I've put down there, these aren't measurements themselves, but I just thought to put them there because just to mention that some larger projects can use things like lowest observed adverse effect level, LOAEL, or the significant observed adverse effect level, SOAEL, and these are sort of set levels in large projects that people will be asked to report on, based on either usually the LAEQ over a particular period. Those values are very dependent on the site. HS2 uses a lot of these, and that's reported on. And that's usually based on having done a previous noise survey and worked out for that environment, for that where they are, those are the levels that they're going to set. So sometimes you'll see those names used. Now I mentioned before that we've got a fixed system, it's unattended. How do we know if we are making too much noise, what is causing it? And for fixed systems, I would always recommend having an audio option on it. And what that means is you can set the system not to record audio continuously at that boundary noise measurement point, but to record unusual pieces of sound when sort of various levels are hit. So you might have an average level of, let's say, 70 decibels at the boundary, but you might be interested in, if it gets to 75, I'd like the system to actually record the sound and log it, that I can listen back to it and then have an understanding of what was causing that noisy, inverted commas, event. And having the audio there is a key way for an unattended monitoring system for you to actually do a bit of investigation into why there is a high level at that particular location. Having that sound will instantly tell you whether it's one of your pieces of equipment or an activity on site, or it's maybe something that's happening on the other side of the boundary fence. One other thing to mention that's sometimes quite useful is weather data. You might have some sites that are pretty wide, open site, and the direction of the wind can have an effect on complaints from certain people. So obviously wind effects can actually make it appear louder sometimes than it actually is, or it can affect people more on some days than on other, and they wonder why it's different one to the other. Having that weather data, knowing the wind speed and direction as a minimum, can help with that. And my sort of head's in the way here, leading the right way. Just to remember, with all of these agreements, there usually will be limits set, so we need to measure limits. So we've got a boundary. There's a picture of a potentially a typical site boundary. It's not very secure, but never mind. It's the equipment and placement is the next section. So what we're going to look at is, yes, you're going to put it there. What do you need to think about when you're actually placing a piece of measurement equipment there? If you're using a handheld, you just walk up to the point, you take a measurement. There's a certain way of doing it with a sound level meter, so arm's length at the correct height, etc. In general, these are the things you need to look for. So first of all, get the right equipment. Is it reliable? Is it flexible? Can you move it? Does it have all the data? Does it meet the right standards, etc.? That's the first thing. And for a fixed system, or even a handheld system, really, you need to make sure that any measurements that you take and where the microphone is positioned is free field. So really, we want to avoid any facades. We want to be, if possible, 3.5 meters away from any vertical walls, so we're not getting any reflective noise to make it appear worse than it is, or giving you a false number. We really don't, if there's trees involved, we don't want to be sat underneath trees. We don't want the drip of the rain from the leaves, and we don't want the noise from the trees, which is just going to, if we've had some of those storms we've had over the last winter, sort of really drown out any other noise. So it needs to be as open as possible and not restricted around it in any way. It needs to be at least 1.2 to 1.5 meters off the ground. That's obviously so we're not getting any reflections or minimizing reflections off the ground. And depending on the way the site is in terms of its topography, you may need to adjust the height of that. So it might need to be behind. So you've got a site which is sort of low down, and the people that have been affected are sort of on a hill nearby. You might adjust the height so it's optimum height for that site, but minimum 1.2 to 1.5 meters. Alignment on the boundary with the nearest receptors if you can. So as I said earlier, you don't want to put it in a corner of the site where you've got no housing nearby. So it needs to be in a sort of a line with where those receptors are. So we're looking to see what's exiting the site and what is likely to be affecting those near neighbours. We've mentioned the standards for the sound level meter. This is the latest one, 61672. At least class 2, and I would say preferably, and you might as well just do it in all cases, class 1 sound level meters. So we've got a system there, and you're putting it in there. What else do we need to think about? So it's on the boundary, it's going to be fixed. Obviously, it doesn't want to be loose. You don't want any flapping cables. You want to tie them down so that you're not getting any noise from any of the equipment. You just want to measure what the sound that's actually there. But a few things for these unattended, remember, fixed systems, which could be there for months. You need to think about power. Can you get a power supply to it of some kind? Is it going to need a solar panel? Can you get away with big batteries, that sort of thing? Because these things do take power. They won't just run on a couple of days for 6 months. You need to think about power. You need to think, and that's why I've put that picture there, weather protection. Obviously, it needs to be a weather protected system because we have sort of 4 seasons in one day in the UK, so it needs to be pretty robust. It's on a construction site as well, so it does need to be pretty robust. These things can get sort of chucked about. And going back to the power, you need to make sure it's, keep an eye on it. Have a system where you know that it's actually live and running, because people charge things up or pinch power supplies and things like that. So it's not just about getting the power to it in the first place, but it's understanding, is it still working? Have I still got power to it? You need to think about that. Communications. This is an important point. With a handheld, you've got all the information in the instrument. You go back, you either take the SIM card, this SD card out, or you download the data to your PC. You've got all that wonderful data there. With a fixed system, you can do the same thing. You could wander up to a laptop, you could take a card out of it and download it later on. But if you're measuring over a long period of time, that's a real pain. So you want a system, in my mind, that's have some sort of communication so you can actually send that data away from the noise monitor and up to a separate system, whether it's a cloud-based system, so everybody's got access to the data, or whether it's a piece of software on your PC. You need that remote communications. That's going to make your life a lot easier to manage the data and to understand what's going on. Because having that sort of live view of the data means that you've got access to the system, and it also means you'll be able to tell pretty quickly if something's gone wrong, so you're not missing any data. A couple of other things to think about with these sort of fixed systems. Security, can it be stolen? That previous picture I showed you, where you've got something on a piece of metal fencing, pretty easy to steal that one, to be honest. Is it securely fixed? Is it fairly secure? Because these things do disappear. Nobody knows why people pinch these. They just think it's a shiny box, and they'll make their way off with it. But it's something else to think about, security. And then, as I mentioned earlier, is it so fixed it's always going to be in that position? So as the site moves its way around to different activities, can that instrument be moved to a more suitable location as and when? So just a few things to think about for data integrity and sort of mounting those systems. So what else should we consider? What I'm going to look at now is sort of alarming, reporting the accuracy of the data that you've captured, and sort of the visibility of the data itself. So alarms. Would it be good to know if we breached a limit that's in our agreement? I think it would. I think it'd be useful to know, and the site can then take a decision as to how it wants to proceed. It would also be useful to know, in my view, whether a limit is going to be breached. So the systems these days that will obviously tell you, well, you breached that alarm, that sort of 5 minutes or that 1 hour alarm level that you've got in there, you breached it for the last hour. What are you going to? Then you can look to see what's happening out there and obviously quiet it down for the rest of the day. Sometimes it's useful to know on that second point is when if you carry on like you are, is it going to be breached, and when is it going to be breached? So at the current noise levels, that's going to breach at some point during the working day. So that's another useful thing that these systems can tell you. And then the site can decide, and I've seen this, either say, yeah, well, we're going to shut that down, we won't do any more, we'll keep within our limits, or actually, we're going to carry on with that. We know we're going to breach it, but at least it gets that job out of the way. Not really the way you should operate, but that's what happens on sites sometimes. And having that information about the breaches, texts, emails, notifications, and logging it in the system, so you can look back at those breaches, those events, is obviously useful to understanding why those occurred. So having those alarms is a useful thing to have, so you can actually act on it quickly, and obviously look back on it and review what was happening. And of course, this leads us into reporting, of course, and reporting is going to be different for each project. It will be. Some projects will need reports weekly, some monthly. It all depends. Some of them can be quite involved. Some just would like a list of, a daily average, a daily maximum, and then, over a month, and then a list of breaches every time you breach that, and maybe some explanation as to what was happening on the site at the time. Some of them can be really more intense. So you've got graphs of sort of daily, maybe hourly data of the LEQ, and maybe some maximum levels in there as well, and looking to see what the daily average was, as well as the the hourly average, and detailed list of breaches, and etc. etc. So it can be very, very varied. So having the ability to produce that information from whatever system you've got is key. Sometimes summarized data is fine. It really just depends on each different project. But what is important is establishing the reporting requirements at a very early stage of the project, i.e. when you get this agreement in place, would be an ideal time. And that would really determine and make sure that you've got the right equipment in place to actually produce the information that the council or whoever else is actually looking for. It might not be the council, it might be the council plus the contractor above you, and it might be something that is obviously released to the general public as well. So having as much information as possible, the right type of information, and being able to process it in the right way for what you've agreed as your reporting requirements is something that needs to be considered at an early stage. Let's look at the accuracy of the data then. Really, you should be using equipment that has obviously had a calibration certificate, so it's been verified before, whether it's a handheld or a fixed system. If you're using a handheld device to do a boundary noise measurement, make sure you field calibrate with something like a calibrator, that cylindrical thing there, before you take a set of measurements and after, to make sure that you're confirming that the instrument is accurate and fit for use. With a fixed system, a lot of these typically have some sort of a self-checking or self-calibration function in there, so they'll automatically self-check themselves a number of times a day. Usually, people typically do it at maybe 1 or 2 o'clock in the morning when it's nice and quiet. They'll check themselves, and you've got a log then of the accuracy of the system, and you can see whether it's starting to trend or it's starting to drift at all. And you can make a decision about whether that information that you've measured is accurate or not. But it's also important to do a field calibration on these fixed systems, typically maybe every 3 months, because even though it's got its own internal measurement checking system, it's always best to put an acoustic calibrator on a regular basis just to check it out. It doesn't harm, and it's probably best practice to do that. So I mentioned data and the visibility of that data. Some projects want to make the data, or have to make the data, depending on how you look at it, available to the council and sometimes to the general public as well. They might insist that information is published maybe on a constructor's website, or people have access to the whatever noise monitoring system you've got in place, like this one here, to look at a subset of that data, so they can see maybe live data, so you can see what the noise levels are, or maybe it's just a summary of the data once a week or something like that, so they can see, the public can see what the actual noise levels on that construction project have been. So sometimes live 24/7 data could be graphical, could be in a table form, is part of that, part of the agreement. And you may want to actually make that available anyway, just as part of your liaison with the local community, to make sure that you're being as helpful as you can, you're being transparent, and you're not actually hiding anything. So this basically builds trust with the local community. So we're going on to the sort of final slide now. We'll have a little bit of time for for questions and answers. So some further considerations then. So we've talked about boundary noise monitoring, and I've given you a few things to think about. Sometimes construction sites are really long term. If they go over a year or more, and you just need to think about, if they are long term, making sure that you do have that periodic verification, or what we call sort of calibration, from a calibration house of some kind. Not just sticking a calibrator on forever, but making sure that you get somebody out, or you send it away, just so that it has that calibration in laboratory conditions, to do that full check of the system. So if you've got something that's a long-term project, make sure that you think about that, build that into the way you're going to manage the system. Another thing to think about is multi-sites. So you might want a system that, you're measuring 3 or 4 different construction sites. You may be a sort of more of a prime contractor, and your job is to monitor the noise. You want a system that can actually give you access to multi-sites at once with all their different monitoring systems. Something else to consider. Also, the way you're actually managing these monitoring systems is something that is always key. So if you're a construction company, are you going to do it internally with your own team? Are you going to use a consultancy to do that, to offer that service for you, put them in, maintain them, etc.? Or sometimes you can go to an equipment supplier like Cirrus. There are others as well who can not only supply the equipment but manage it for you, just like a consultancy could. So there's different ways of managing it. Some sites just buy one system, and they've got some person on site that does it all. The problem with doing it that way is, people move jobs quite a lot these days, particularly since COVID, and keeping the skill set up to manage, a technical system like that is not always easy if people are moving around. So different ways of doing it, but it's just something you need to consider how it's going to be managed. And then finally, the last thought is, I've just mentioned noise, and we all know with construction sites, then sort of ground-borne vibration, dust, even depending on the site, other types of pollutants can be measured. If that is a key thing for you, do you want an integrated system? Are you happy with separate systems for each of these? Wouldn't it be great if you had all that data in one place? So sometimes you're not just thinking about noise, you're thinking about some of these other environmental pollutants at the same time, to make sure that you're capturing everything you need to capture, exiting the site and affecting the local community, because that's what this is all about. We're not interested in how loud it is at the bottom of a hole 50 meters into a construction site. We're interested in what's affecting the local community. So boundary noise monitoring is a great way of doing that, and I hope that what I've talked about today just give you a few a few things to think about, and I hope you've enjoyed what I've had to say. So without further ado, what I'll do is I shall stop sharing my screen and go back to the main webcam in a second. There we go. And we shall have a look at some of whether we've had any chat on here. And then I'll have a little look and see if we've got any questions. And I think I've got any. So what I'll do is I'll just see if anybody has got any questions. If you want to raise your hand, if you've got any questions, I'll see if I can take you off mute, and you'll be able to mention it. If anybody's got any questions, please, by all means, go ahead and raise your hand, and we'll see if anybody's got anything. Okay, I can't actually see anybody raising their hand, and I can't see anything in the chat, which is fine. Obviously, it's been perfect, and you've got all the information you need to know, which is great. So I'd just like to thank everybody for attending today. And as I say, if you've got any questions on this separately, if you want to email sales@cirrusresearch.com, we'll be able to get back to you, and we can engage in a conversation directly if you wish. I'd like to thank everybody for attending, and have a great rest of the day. Thank you. Bye-bye.